In this video, I am going to review the Chapter 2 problems that were assigned. This would be number 10, number 14, and number 15 in your textbook at the end of Chapter 2. So we're going to look at index values, indices, and nominal and real values. So to summarize some of the terms that were introduced, we're going to start with indices. So plural form is indices, singular form is index, but an index is a value. It can be either in a decimal or in a percentage that allows us to compare either production or price of a product from one year to another. So if we take a look at this example over here, we're looking at the output price indices for milk from the year 1995 to 2015. So if we were a dairy farmer, we might be interested in some of this data. So the first thing that we need to do is we need to identify our base year. So our base year is going to be the year in which all of the output indices, all of these indices, as well as all of the price indices are compared to. Okay, so in this example, our base year, all we have to do to find our base year is to look at to find the year that has an index value of 1.00. As we can see in the definition here, a base year is assigned an index value of 1.00 or 100%, and the base year is which all of the other, a base year is the year in which all of the other years' production and price are compared to. Let's define the production really quickly. So when we talk about milk production, we think of that in pounds. So farmers get paid actually a certain number of dollars per 100 pounds of milk that is produced. That's what that CWT is. C stands for 100, and then the WT stands for weight, so 100 weight. So the prices over here in 1995, they were getting $12.74 per 100 pounds. Okay, and then our production is the same as output. So we're using those two terms synonymously. We're saying our output in pounds, or in this case in millions of pounds, is going to be translated as our output. Okay, so for this, how the index values for each year are calculated is pretty simple. So again, I'm going to highlight our base year, which is the year 2000. We know that's our base year because it has an index value of 1.00. And we can see that all of these years before 2000 have index values lower than that 2000 index value. What that means, so a lower index in this case for the output, so let's say a lower output index means that production of milk was lower in that year compared to the base year. In this case, our base year is 2000. Well, we might ask, well, how much lower was it? In this case, if we translate these into percentages, so if we consider that 2000 was 100%, then we see that 1999 was at 97% of that base year production. That means we were producing 3% less. So 97% of the 2000 of the year 2000 value was being produced in 1999. I may ask, what percent, how much less was being produced in 1995 compared to the base year of 2000? Well, if 2000 is at 100% here, 1995 is at 93%, we can say it was 7% less production. Okay, that goes the opposite way as well. We can see some numbers here are increasing as we get later and later. So 2001 is actually 1% less because it's at 0.99. However, let's look at 2010. 2010, we are at 1.15. So 1.15 is actually, can be translated into 115%. So from 2000 to 2010, we are producing 15% more pounds of milk. Okay, how did we get that number? I still haven't told you that yet. So the equation basically for calculating index values is, I'll write that for you here. So I'm going to write the index value of desired year, we'll just say, because you may be interested in a whole bunch of different years. So the index value of the desired year equals production output of desired year divided by production output of base year. And I actually should write the index value. I should write, in this case, we're looking at output. So we're looking at the production. So output index value of desired year equals the production in pounds of desired year divided by the production in pounds of the base year. And that's going to give us our decimal. And then if we want to change it to percent, we can. So let's check and see if one of these numbers is correct. So let's just go ahead and see if 2012 has the correct index value according to our equation. So according to our equation, the output index value of the desired year, so 2012 is my desired year, should equal the production output of that desired year. So the production output is this 200,366 pounds, million pounds. So 200,366 divided by the production output of the base year. Okay, my base year is, we got to find, is 2000 because it's at that 1.00. And the production output of that base year is 167,393. So if I take my calculator and divide that, 200,366 divided by 167,393, I get 1.969. So I'm going to say 1.97. They must have rounded it to get that 1.2, which is fine. Okay, so again, this means that it is greater than the base year. The production is greater than the base year, and it is greater by 20%, because again, if we change these both to percentages, our 1.00 becomes 100%, and our 1.20 becomes 120%, and then we have increased the difference between 100% and 120% is an increase in 20%. Production. So this is for pounds of milk output production. Okay, now we can do index values for price as well. So I'm going to erase all this and we're going to look at this price example. So this chart has a lot of information on it because, as I mentioned, it has the output index, which is the production, and it has the price index, which is obviously the price, the dollars that the farmer is receiving. So if we wanted to, if I asked you what, let's just say, how much greater is the price in 2008 from the base year? So our base year, we're still talking about the same chart here, is 1.00, but now we are looking at these numbers. Okay, again, if we change this to a percent, we have 100% here, we have 149% here. So the price increased by 49% from 2000, to 2008. Okay, so we can think of index values in terms of decimals or percents, but it kind of helps us, it helps me when I think about it in percents. It helps me understand it a little better. So just because we're on this, let's go ahead and check one of their values for the price index. And let's change our equation up here. So we have output index value of desired year. Let's change that to, if we're trying to calculate the price index value for a desired year, that's going to be then not the production output. That's going to be the price of the desired year that we're looking at divided by the price of the base year. The base year for this chart and for any particular set of data never changes. So let's do the year 2000. Oh no, our base year is 2000. Let's do 2014. Okay, and let's see if they got that correct. So that's our desired year. So the price index value, so we're checking this 1.95 to see if they got that correct. The price index value of the desired year equals the price for the desired year. So our price for 100 pounds of milk in 2014 was $23.97. For those of you who are dairy farmers, that would be awesome if the price of milk was $23.97. Divided by the price of the base year. So again, our base year is 2000 and the price then was $12.32. So if we divide those, let's go ahead and do that. $23.97 divided by $12.32, I get 1.945, but that would round up to 1.95. So that is correct, and that's how they calculated that price index. Okay, so we're going to go on to the next slide here. Okay, so we're going to do an example here out of your textbook. So we are looking for the output indices of this slaughtering plant, and our base year is 2014. So again, output usually refers to production. In this case, it is pounds of cattle. So if our base year is 2014, we automatically know that our output index is 1.00. Okay, I would also accept 100%. So if you're doing it in a decimal, just leave the percent off, and then if you change it to percent, multiply it times 100 and put the percent on there. Now we need to develop the output indices for the other two. So if you remember our equation, output index equals output of desired year divided by output base year. So our output of desired year, well, we want to figure them both out. So let's start with 2013. Our output of the desired year is 180,000. We're going to divide that by our base year, which is 250,000. And if we do that, grab my calculator, 180,000 divided by 250,000, I get 0.72. So my output index is going to be 0.72 or 72%. And then 2014, we already know that, but if we didn't know that, our output of our desired year would be 2,000 or 250,000. Our desired year is also our base year, so that's also 250,000, and that's going to be 1. So that makes sense. Okay, and then our final calculation that we have to do is for the year 2015. So 2015, our desired output is 200,000, and we're going to divide that by our base year output, which is 250,000. If I do that in my calculator, I get 0.08, so I could either do, or not 0.08, 0.80 or 80%. Okay, so that's what we were looking for number 10. Hope that helps. The next slide that we have here is talking about real versus nominal values. Okay, so we know that inflation exists. So what $20 these days is not worth as much as $20 was worth 50 years ago. $20 was a lot of money 50 years ago, and $20 is not a lot of money these years. I know that my parents could buy a brand new car several years ago, well, probably 40 or 50 years ago, for $2,000. We cannot buy a brand new car these days for $2,000. That's because of inflation, okay? So it's really hard to compare nominal values of money today compared to nominal values of money 40 and 50 and 60 years ago. So in order to compare the money now and historical money, we need to be able to calculate real values. So it kind of accounts for, real values account for inflation and allow us to figure out, you know, whether we really are making more money with taking inflation into account. So there's a equation that allows us to calculate this, and that's what I've circled right here. The equation is you take the real value equals the nominal value divided by the consumer price index. This should say nominal value divided by consumer price index. The consumer price index, again, there's going to be a base year involved with that, but it's going to be a percent or a decimal. In the example that we have down here, it's 2.5, which helps us think about how much money, how many dollars that consumers pay for goods and services compared to a base year. So, you know, how much money do people spend on groceries and getting their hair cut and getting their oil changed and paying for their driveway to be plowed. So there's all goods and services that people pay for. So the amount of money that they are spending is going to be relative to the amount of money that they are making, and that's kind of how we're able to calculate for or consider inflation. Okay, so you don't need to completely understand that. There's a little bit more in your textbook about that, but let's focus on this equation. So in this case, we have the consumer price index is 2.5. So again, that's going to be 250%. Well, not 250, that's going to be at 250%, where the base year would be at 100%. So this is going to be 150% greater than the base year. Okay, not super important, but just to put that in perspective, that the consumer price index for 2012 is going to be higher than what the base year is in this example. Okay, so let's get to this actual question. So this question says, suppose your nominal income in 1995 was $24,000. Suppose too that the consumer price index for 2012 was 2.5 and that the base year for this index is 1995. Okay, so we're comparing everything to 1995 here. How much nominal income would you need in 2012 in order to match the spending power of your $24,000 in 1995? Okay, so let's fill in the information that we can into this equation. Okay, so we are interested in the real value of our, we're looking at 1995, and we have the consumer price index for 2012 was 2.5. So we have the bottom part of this equation, 2.5. The nominal value is what we are looking for. How much nominal income would you need in 2012? We do not know that. In order to match the spending power of your $24,000 in 1995. So this $24,000 is actually going to be our real value in this case. And it is this way because they've told us that 1995 is the base year. So that's the comparison that we are looking for. So in order to match that $24,000, we need to calculate this out. So how are we going to solve for the question mark here? Well, if you guys have done cross multiplying and dividing, you're just going to take $24,000 times 2.5. Why do we do that? Because we know that consumers are spending 2.5 times more than they used to spend, so they need to make 2.5 times more than what they are making now. We know that this is 1 underneath there. So we're going to cross multiply 24,000 times 2.5, and if I do that, that's 60,000, and then we could divide it by 1, but that's going to be the same answer. So we need to be making $60,000 in 2012 to match our $24,000 in 1995, because the consumer price index is now at 2.5. So we need to make 2.5 times more money. Okay, I hope that's a little bit clearer. It is a confusing concept, but hopefully that helped you out. Okay, we're on the last problem now. So this is multiple steps to this problem. I'm going to cross some information out that we don't need right away. Let me try to do that. Okay, we don't need to worry about this information yet for the first couple problems. And let's see if I can write over that. Okay, so we are given our output in bushels, so some sort of crop that has been produced. So this output here is in bushels. The price is in dollars per bushel that they're going to sell their crop for. Okay, so the first question that's being asked is, what is the output index for 2010? So in 2010, and it says let the base year be 2011. So we already know that the base, output index. So they want to know the output index, and then they are going to ask us for the price index too. So I'm going to put that in here right now. Okay, they already told us that the base year is 2011. Immediately when you know what the base year is, the index is 1.00, or whether we're talking about output or price. Okay, that's also 100%. So that's with our other two measures are going to be compared to 2011. Okay, so the first question asks, for 2010, what is the output index? Well, output in 2010 was 70,000. So if you recall our equation, output index of desired year equals output desired year divided by output base year. Okay, the output of our desired year is 70,000. The output of our base year is 75,000. 70,000 divided by 75,000 equals 0.93. 0.93. And then it says interpret this measure. Well, this means that, so this was at 93%. If I was going to interpret that, I would say something like production in 2010 was 7% less. That's 100 minus 93 than production in 2011. Okay, so that's A. I'm going to do some erasing. Oh, I probably didn't need to erase all that. Okay, so part B says, for the year 2012, what is the price index? Okay, so if we're calculating price index of desired year equals price of desired year divided by price base year. So price of our desired year is 2012, and our price of 2012 is $2.80 divided by the price of our base year. Price of our base year is $2.90. So 290 or 280 divided by 290 equals 0.97. So our price index for 2012 is 0.97, and that is 97%. Also, it says interpret this measure. I would say something like the price in 2012 was 3% less than the price in 2011. So that's how you can interpret that. Okay, part C is a little bit trickier, and it brings in all of these parts that I erased. Okay, so let me erase all of this. And then we will get to part C. Okay, so part C. Assume that the only source of income for this farmer is from the production of this output. What is the best year in terms of real income? So we're going to have to recall this equation. Real value equals nominal value divided by CPI. Okay, and we have the CPIs here for all those years. I'm going to get rid of some of this stuff. Okay, so first we need to figure out, let's figure out how much money was made in each of these years. So in 2010, 2011, and 2012. So in 2010, 70,000 bushels was produced, and we sold those 70,000 bushels for $3.20. So our gross income, 70,000 times 320, is $224,000. We're not done though, because we had some production expenses. So our production expenses were $120,000. We have to subtract those off. So 224,000 minus 120,000 equals equals $104,000. So that is our nominal value. That's the actual money that we made that year. In order to find our real value, we need to divide it by the consumer price index for that year. So the consumer price index for that year is 1.10. So if we do 104,000 divided by 1.10, we get $94,545.45. So this is my real value for 2010. I now need to calculate my real value for 2011 and my real value for 2012, the same way that I calculated it for 2010. Once I finish that, the highest number is going to be the best year in terms of real income. Okay, so I'm going to let you go ahead and finish that out on your own, and I hope this video helped you to understand the homework for Chapter 2. If you have any additional questions, please don't hesitate to contact me. Thank you.